Everybody, how are you all today? You're all good? Excellent, very good. So my name's Rod, and as you just heard, I'm a particle cosmologist or a particle physicist. So I want to talk to you a little bit about what it is I do in my job, what does a particle physicist do, and in answering that question, we're going to talk about what the universe is made of. So if you were cooking up the universe from scratch, I want to tell you about what ingredients you need to build a universe, okay? So let's get right into it. So, we're going to be talking, first of all, about matter. So, matter is stuff that has weight. You know, a chair is made of matter, we're made of matter, the air is made of matter, water is made of matter. All the sort of solid and liquid and gas things that you see around you are made of matter. So, everything you can touch, and feel, and smell is mostly made of matter. Now, can anyone think of something you can feel or see that maybe is not made of matter? Yeah. What was that? Light. Very good. Brilliant. That's exactly right. Anything else? Yeah. Say again. Darkness. Well, that's an interesting one because darkness is sort of just like when you have no light, isn't it? So I'm going to count that was. Yeah. Computers are made out of matter. All the little circuits and all the little stuff like that, that's got matter in it. Yeah. What do you think? You forgot that slide, didn't you? Sorry? No, paper is matter. Paper is made out of trees, isn't it? So that's made of matter. One more, yeah. Flame, that's an interesting one. So part of the flame, what comes out of the flame is not matter, you're right. The flame itself is actually a sort of glowing thing we call plasma, which is a kind of matter. But one thing that is not matter that comes from a flame is heat. So light and heat are what we call energy. So energy is different to matter. Energy is what makes matter do stuff. It's what makes it move. You know, when you get up in the morning and you have your breakfast, it gives you energy so you can do something. And maybe that something is running upstairs or running around playing football. But energy is something that matter has that lets matter do stuff. Okay? Now, I want to talk a little bit about what matter is made of. So we're focusing on matter, which is stuff. Okay? Chairs, people, carrots, apples, bananas, all that stuff. So I'm going to start by talking about three particle physicists. So one of these is me, the other two are two of my colleagues and supervisors. And what we're going to do is we're going to zoom in a little bit. You can see there the magnifying glass on my face. Don't worry, you're not just going to have to look at my face super close. If we zoom in really far on a human face, you reach a cell. Okay? Now I'm not a biologist, so I don't know very much about cells, but all of our bodies are made up of millions and millions and millions of tiny little cells. Okay? These little sort of living pieces that make up a living body. Okay? Now what if we zoom even further, what if I take my magnifying glass and I look in even more detail at the cell? We get to the atom. Okay? So atoms, this actually comes from the Greek word, which means indivisible. So the Greeks, the ancient Greeks, thought that you could never have anything smaller than an atom. Is that true? Is there anything smaller than an atom? Yeah, what do you think? Very old, skipping way ahead. Brilliant, very good. So the pieces inside of the atom, absolutely. So this is what particle physicists do. We look at stuff, we look at matter, and we try and zoom in on it as far as we can and see what is this made of? What is that stuff made of that made up the other thing? So we're always trying to zoom in. So let's look even closer to the atom. So I'm going to zoom in here on the center of the atom, which is called the nucleus. And I find these two smaller pieces that make it up, these two little sort of Lego bricks that make up the nucleus of the atom. So one of these is called a proton, one of these is called a neutron. And these are kinds of particles. So this is where the particle part comes in my job title as a particle physicist. Particles are the tiny little pieces of matter that make up all the other bigger bits of matter. Okay? Now, can I zoom in even further? Can I look even further at the proton, for example? Indeed I can. If we zoom in and look inside of the proton, we find it is made of even smaller pieces, like the young man there told us. The proton is made up of what we call quarks. Okay? Now, can know what a quark is made of? Yeah? Say again? It's a form of matter, certainly. All these particles are matter. But what is it made of? Does it have smaller pieces inside it? Yeah, what do you think? Plasma? Ooh, plasma is something different. Plasma is very interesting, but not quite. Okay? So the quark, if you zoom in on it, it's not got anything inside. The quark is just a quark. Okay? Quarks just are. Okay? So when you zoom in and you zoom in further and further and further, you eventually reach what we call elementary particles, which are things you can't zoom in on anymore. Okay? This is like, you've got a Lego set, you've got a Lego house, and you start pulling it apart, smashing it up and breaking it apart. Eventually you break it down to a tiny little Lego brick. And you can't break that Lego brick up anymore, can you? That's the smallest little piece you've got in your Lego house. So quarks are fundamental. They can't be broken up into any small pieces. They are the smallest little thing that we have to do with us. Okay? So, as a particle physicist, now this is a really complicated diagram, so don't worry about all the numbers and all the names. But as a particle physicist, my job is to try and figure out all of these other little pieces of matter that can't be broken up anymore. So quarks are one example, but there are a few others. There's a whole family here called leptons. There's a family up here that are the quarks, and then there are these other particles called bosons. So physicists are really not very creative at coming up with names. We just sort of make up funny sounds for the particles. Bosons, fermions, muons, leptons. But this is our list of ingredients. For if you were cooking up the universe, what would you need in order to make it? What I'm interested in is that everything. So quarks, leptons, electrons, if you've heard of any of these. Is there anything that's not shown here? Is there any kind of matter that I'm not listed? Yeah, but very good. Very, very good. Antimatter. Who has heard of antimatter? A few of you. So it sounds quite sci-fi, doesn't it? It's very sort of, warp factor 10 kind of sci-fi. But antimatter is all around us. Okay? Now, what is it? It weighs the same as regular matter. Okay? Remember, matter is something that has a weight. You can pick up a piece of matter. Antimatter also has a weight, but some of its properties are reversed. It's kind of like a sort of mirror image of matter. So here, for example, I've shown you an electron, which is the particle that spins around the center of the atom in all matter, and its antiparticle, called the positron, the anti-electron. Now you can sort of think of the positron as being like the evil twin of the electron. Okay? So it's the same size, but it has some opposite properties. Now, what I'm interested in is what happens when you combine matter and antimatter. I'll come to you in a minute. So when you combine matter and antimatter, when you smush them together, something really interesting happens. We say they annihilate. Now what happens when they annihilate? Does anyone know? Yeah, you would do. So they disappear, you're right, they sort of destroy themselves. But in that process, where they sort of disappear, they collide and they vanish, they release huge amounts of energy. Okay? So the particles disappear when the matter and antimatter touch, then boom, they're gone, but they release a huge amount of energy. Okay? Now, so one of the uses we might have for antimatter in the future is if we were ever to be able to travel to other galaxies, we invented some kind of spacecraft that would take us millions and millions of light years away, we probably have to power it by antimatter. Okay? Now, a side question, can anyone tell me what is a galaxy? I mentioned another galaxy. What do I mean by this? So, yeah, planet goes around. So the solar system is planets in it. Now, a galaxy may be lots of different solar systems. So the galaxy has lots of planets in it, that's for sure. So the galaxy contains billions and billions of stars, okay, just like our sun, our solar system. So galaxies are huge collections of stars. Now, I'm going to need a volunteer for this. So, I have in my bag an antimatter generator. And I'm going to need one of you to help me take it out. So who wants to come up? Okay, you're very close, you can come up. Okay. So when you come up, be careful. But I want you to grab it and I want you to hold it above your head. Ah! A banana! Okay. So what's going on here? Thank you very much. Very good. So what's going on here? Bananas, if you didn't know, produce antimatter. Bananas have within them something called potassium, which you also have in your body, so you also make a little bit of antimatter. And the potassium atoms within the banana, they are slightly radioactive. So what happens is they will turn from potassium into a different kind of substance. So they'll turn into calcium, which is also something you have in your body, in your teeth, and in your bones. And when they turn into calcium, they release a very tiny amount of antimatter. So they release these anti-electrons we spoke about before. So bananas contain a very small amount of antimatter. It's not a dangerous amount because it's very, very tiny. So you can still eat your bananas. They're not dangerous to you. But they have inside a very small amount of antimatter. Okay? Now, I went to the next slide a little bit more quickly. Can anyone tell me another kind of, matter that we haven't spoken about? Dark matter, very good. Now, dark matter is extremely mysterious. So, dark matter makes up about 85% of all of the matter in our universe. So, if you look at this little pie chart here, that little green sliver is all the regular matter that we're made of, that the Earth is made of, that the Sun is made of. And this big slice here, this is all antimatter. No, it's not, sorry, it's all dark matter. I've labelled it wrong. Ignore that, it's not antimatter, it's dark matter. Okay, this completely invisible, totally mysterious kind of stuff that we don't know what it's made of. Okay? Now, if it's invisible, how do we know it's there? So we know it's there by looking at all the different galaxies in our universe and looking specifically at the way that the galaxies spin. Now, we can't explain how the galaxies spin the way they do unless they have dark matter within them. So by looking at how they spin, we know they must contain huge amounts of dark matter. It's invisible, you can't touch it, it's dark matter passing through your bodies right now, but it doesn't, you can't feel it and you can't smell it or anything like that. We can't explain what it is yet, but it's something we're trying to work out really hard. So one last thing I wanted to show you, or I wanted to talk to you about, is how do you become a particle physicist? Maybe you found some of this interesting. You might want to become a scientist of some kind, and particle physics is a great one to get into. So what do we have to do? First of all, you have to work really hard in science and in maths and numeracy. Okay? Because it's not just about science, you've got to be good with numbers too. So numeracy is really important. You've got to be curious, you've got to ask lots of questions. Okay? And I'm looking forward to taking some questions from the next group when we talk about black holes in a little while. You've got to enjoy solving tough problems. Now, the word problem, when we talk about maths problems, I don't think is a great name because it makes it sound like a bad thing. But actually, having a maths problem is a really good thing. Okay? It's good to have difficult, challenging things to do. Okay? And last of all, you have to believe in yourself because anyone can be a scientist. You just have to be interested and you just have to be curious, and then anyone can do science. Okay? Well, that's all I wanted to say, and it was lovely talking to you all. Okay.